Hello students, I am Dr. Nimi Singh. Today I bring you the next learning episode on a very important unit of paper, Criminalistics, that is Forensic Significance of Fiber, its part 2. Students, recollect that in the last module, which is Forensic Significance of Fiber part 1, we had studied about fiber and its classification. We also studied about class and individual characteristics of fiber. In addition to it, you also studied about collection, handling, preservation of fiber and how fiber is used as an evidence in crime scene investigation. Dear students, in this lecture, we will be studying about the comparison of shape and structure of various fibers along with comparison of physical properties of matter. You will also get to know about the examinations carried out in case of fibers. We will then wind up this module with a conclusion. Let's start our today's lecture with a look at what we are going to learn today. Module number 1, it is going to be the comparison of shape and structure of various fibers. Then we will do comparison of physical properties of fiber and then the examination of fiber. Now, let us start our lecture series with comparison of shape and structure of various fibers. Now, after the fiber evidence has been properly collected, it is then sent to the forensic science laboratory with the purpose of examination and comparison. The comparison of fiber evidence is carried out with the help of microscope. The fiber examiner at the least should use a comparison microscope, a stereo microscope and a compound light microscope having the polarized light capability. The questioned and the reference fibers must be viewed on simultaneously or side by side by the fiber examiner and at the same magnification in visible light and alternative lighting, for example, polarized light or fluorescent light, though being not necessary is recommended if the equipment allows. For some analysis, for example, in testing for solubility, it may be necessary to place the questioned and the known fibers next to each other on the same slide or in adjacent walls of a spot plate. Precautions should be taken in case of loose fibers and in these types of situations such that the source of the fiber is not confused with some other sample. Let us come to the comparison. Usually, the examination of fiber comprises of the comparison between the reference and unknown samples for the determination of the source of a region, that is, whether they are from the same source or not. For example, carpet from a suspect's car compared with foreign fibers removed from the victim's clothing. The comparison is based on the recognition and evaluation of the class characteristics, wherein the sample is associated with a class or group and never to a single source. Conversely, individual characteristics allow the association between two or more items with each other by the exclusion of all other items. This situation mostly arises for fiber examiners when they are carrying out mechanical fit or physical matching of pieces of fabric or cordage. Fibers, which are either natural or synthetic, are easily transferred from objects to persons or from person to person. If collected and examined properly, they can establish a relationship between objects and or persons. With the exception of DNA analysis, fibers are examined in almost in the same manner as the hair. When control fibers are available for comparison, a match is often made with a high degree of certainty. In the absence of control fibers, an experienced observer can provide valuable insight on the origin of a fiber. They may be able to predict if such a fiber originated from clothes, towels, carpet or other sources. Let us come to the comparison of the physical properties of fiber. fiber has an important evidentiary value in the field of forensic science. It provides the following variety of the clue materials like individual fibers, threads, a piece of cloth, a clothing, a cord string, ropes or their pieces, woolen fibers, furs, etc. It can determine the source if a questioned fiber exhibits the same chemical, microscopic and optical properties to that of a fiber from a known source. A comparison requires an examiner to complete at least two of the analytical techniques for the characteristics like generic class, physical characteristics and color. Physical properties like density, refractive index, melting or softening point and tensile strength give important information about the fiber. Cross-sectional study of fibers reveal structural features that are otherwise difficult to comprehend. The following optical properties are very useful for fiber identification like the refractive index, birefringence and the fiber elongation. Fluorescence is also very important for the examination purposes. The examination is done by observing the presence or the absence of fluorescence, color and intensity of the fluorescence and the exciting wavelength. There are various techniques, processes and determination which are made for the examination of fibers. In forensic science, fibers are nothing but trace evidence which are used to create a link between the crime and the suspect. A fiber can be defined as the smallest unit of the textile material having length many times greater than its diameter. A fabric is defined as the knitted or the woven forms of fibers. The transference and the significance of fiber association is affected by the type of fiber construction, spinning method employed, the type and the length of the fiber. These properties, they serve as important clue during the commission of crime by showing the possibility of fiber transference between a victim and the suspect. Matching and comparison of exceptional fibers is very useful in cases of investigation wherein certain fibers have been transferred between suspect and the victim. However, matching of common fibers such as the blue denim or white cotton proves to be less helpful. The likelihood that the two individuals had physical contact can be dramatically proven if cross transfers and multiple transfers of fibers are discovered between the clothing of suspect and that of the victim. There are certain crucial physical characteristics that make the comparison easy, which are the fiber diameter. Now, the fibers vary in size from 10 to 15 micrometers. The softer materials will have the smallest fibers, while the most durable materials will have the largest fibers. The fiber diameter is compared for the questioned and the reference sample so that their source can be determined. Then is the fiber cross section. Basically, it is the cross section of the fiber that varies according to the type of the fiber. The natural fibers have their origin from plants and animals and thus look rough at the edges. This feature on examination can actually reveal whether the fiber is a natural or a man-made. There are various types of cross-section in case of fibers such as round, trilobal, dumbbell, flat and multi-lobed. Then comes the fiber number. The number of fibers on the clothing of a victim can be actually identified that from the clothings of the suspect transferred because of the physical contact. The greater is the number of fibers, it is more likely that contact actually occurred between these individuals. Then comes the fiber color. Now, fiber color actually influences the value of particular fiber identification. Often dyes are used to give colors. Individual fibers may also be dyed before being spun into yarns. Also, color can be applied to the surface of the fabric as found in printed fabrics. Thus, how color is applied and absorbed along the length of the fiber are very important comparison characteristics. Color fading and discoloration can also lend increased value to a fabric association. Then is the density. Now, density of water is 1 grams per milliliter. Olefin is the only fiber that will float in water. Then is the refractive index. Now, the bending of light as it passes from air into solid or liquid is what you call as the refraction of light. The investigators, they measure the refractive index of an unknown sample with the liquids of a known refractive index. The samples are placed in different liquids until backline is no longer visible. Then is the fluorescence. Some fibers will fluoresce when exposed to UV light. Some fibers will fluoresce when exposed to UV light. Laundry soap and some bleach have whitening agent that cause blue light to be reflected, making it appear white. Solubility and decomposition. The solubility and decomposition of a fiber is tested using strong acids such as hydrochloric acid or sulfuric acid, or strong bases such as NaOCl, acetone, NaOH, that is the sodium hydroxide. This determines the fabric's polymers. Then is the burn test. The fiber is burnt on the Bunsen flame to see how it burns, its odor and appearance of ash. Then is the thermal decomposition. The fibers are heated so as to check how the fibers break down when heated. A comparison actually requires an examiner to complete at least 2 of the analytical techniques listed for each of the following categories: the generic class, physical characteristics and color. The techniques selected should independently confirm the results obtained. It should also be noted that some techniques allow greater discrimination than others between apparently similar samples. The results to be reported should be in a uniform and consistent manner. Format, units of measurement and accepted calculations should all be documented in the laboratory's manual. The contributor of the evidence must be able to interpret the results. Let us now come to the examination of fiber. The main evaluation techniques for the fibrous evidence follow the general pattern of evaluating the micro traces. However, there are specific determinations to be made. The following techniques, processes and determinations are made. The preliminary examination is done first. The fibers are examined visually with a hand magnifier and under a stereo microscope. The study includes the twist of the thread, string, rope or cord, the number of strands, the number of threads in the string, the number of fibers in each thread, the defect in the thread or weave pattern, the thread counts of cloth both in weft and wrap, if recovered torn piece of cloth originally formed part of the standard provided, a mechanical fit may indicate the common source. Now, physical matches or mechanical fit. A physical match occurs when 2 or more pieces of fabric or cordage are reconstructed to prove that they were previously one continuous piece of a fabric or cordage. This examination is conducted by describing and documenting any cut, torn or damaged edges on questioned items and the correlation to like areas on known items. Photography is the recommended method of documentation. Depending upon sample size, suitability and exhibit characteristics, it may not be possible to effect a positive physical match. Then is the microscopic examination. A microscope is the most important tool of a forensic science laboratory. It is needed in all branches of forensic science. For example, scanning electron microscope is becoming an indispensable part in forensic micro trace analysis. At a minimum, a fiber examiner must employ a stereo microscope, a comparison microscope and a compound light microscope equipped with a polarized light capability. A collection of known samples can be made of which only a fiber or 2 is needed to be mounted alongside an unknown to give you a great deal of assurance in making your identification. Alternatively, you could assemble a set of permanent slides to give you a known sample to compare with an unknown. In a fabric with yarns of different colors, you should really look at each color separately. Microscopic examination is actually useful in the following findings: the structure of fiber, the nature of fiber materials, the diameter of the fiber, the presence or absence of contamination, color of the fiber, cross-sectional structure, inclusions including delustering agents, adhering materials, process failure defects, damages, aberrations, wear. Now, use of ultraviolet rays and polarized light microscope extend the microscope examination and provides additional discriminating data. Microscopy is an essential element in almost all aspects of forensic examination and comparison of fibers. One of the most fundamental level microscopes are necessary to see fibrous evidence no matter what observation or test are being performed. Thus, microscopic observation is used to detect fibers, to characterize them and in most cases to compare them to the suspect sources. There are some common microscopes which are used in identification and examination of fiber. Let us discuss them in brief. The first one, the Syria Microscope. This is used for low magnifications where there is long working distance and upright images assist in searching small items of evidence or tapes and in recovery and manipulation of individual fibers. Then is the Polarizing Microscope. The Polarizing Microscope is similar to a conventional biological microscope with additional features which facilitate observations and measurements with plain polarized light. There is a Comparison Microscope. Now, this instrument actually permits the direct comparison of such fiber properties such as morphology, diameter and color. The fiber samples which are to be compared are kept side by side on two stages and comparison is thus carried out. Now, fluorescence microscope. This microscope is of modern design equipped for incident illumination. This microscope employs fluorescence and phosphorescence along with reflection and absorption to study the characteristic properties of the sample. Now, then is a scanning electron microscopy. The microscopic examination is useful to find out the structure, nature, diameter, presence or absence of contamination, color and the cross-sectional structure. Scanning electron microscopy, that is SEM, is a method of photography which requires instrument called the scanning electron microscope, which uses electrons rather than light to form an image. Then is the atomic force microscopy. Now, atomic force microscopy is a method which is carried out using an atomic force microscope. It is an instrument to analyze and characterize samples at the microscopic level. The instrument will allow an analyst to look at the surface characteristics with very accurate resolution ranging from 100 micrometers to even less than 1 micrometer. Study of physical and chemical properties. Now, coming to this, various properties of fibers are first studied starting with fiber diameter, cross section, color, number of fibers present on the surface, solubility and decomposition and melting point. In addition to these, the chemical and optical properties are also studied for the purpose of examination. Cross-sectional study of fibers reveals structural features that are otherwise difficult to comprehend. The technique is similar to the one which is employed in the study of hair. The cross-sections of fibers are obtained with the help of an instrument called microtome. Clean fiber is embedded in hard wax, plastics or flesh which is hardened by some special treatment and then sliced. The cross-sections of fibers obtained are placed on a microscopic slide treated with albumin. Microscopy reveals the cross-sectional structure of fibers. Now, here in the table which you can see on your screen, we have shown the characteristic features of fibers under different conditions. Let us come to the characteristic features of fiber under different conditions. We will first have the sample, then the physical examination, then specific gravity, then burning examination, then microscopic examination. Coming to the first sample, which is cotton. The physical examination shows it is white colored thread, rough in touch, high crystalline, hydrophilic in nature, cannot dissolve in common solvent. The specific gravity is 1.54, and if we do the burning examination, in flame it ignites immediately and gets easily converted into ash. Under microscopic examination, single elongated cell, spirally twisted ribbon and tube-like structure. Then comes the cotton. Now here, cotton fiber is nothing but brownish in color, hard and rough to touch, with specific gravity 1.35, and in flame non-continuous burning is seen, which converts into ash easily, and fiber has a single and elongated thread-like structure. Coming to wool. Now the nodal point of the thread is black in color, which is warm to touch. With a specific gravity 1.25, it burns slowly and converts into ash as small beads. On microscopic examination, we see that fiber has irregular, roughly cylindrical, multicellular structure with tapered ends. Then is the jute. Now jute is rough and it feels cool to touch. With a specific gravity 1.50, it ignites immediately, continuously burn, and after complete burning convert into light colored ash. This fiber has non-continuous filaments. Then comes the silk fiber. It has got a shining appearance, is sticky to touch, it has moderate electrical resistivity with specific gravity between 1.25 and 1.30. It burns slowly and self-extinguishable. This fiber has fine and lustrous filament which is triangular and rod shaped in structure. Then is the polyester. Now it has a moderate recovery from low elongations, moderate heat conductivity, high resistivity, shining appearance, feels sticky to touch with a specific gravity 1.38. On burning, the thread of this fiber melts slowly, self-extinguishable, converts into ash like brittle beads. Fiber has smooth and straight threads like appearance. Then is the glass. It has smooth and straight thread-like structure. With a specific gravity 2.5, it does not burn on heating. Flame can melt the fiber significantly, no conversion in ash. It has smooth, rounded, transparent, shiny and flexible thread. Then is the nylon. Now nylon has a strong, is perfectly elastic, quite stiff and brittle structure with specific gravity between 1.30 and 1.35. On burning, it melts slowly, it is self-extinguishable, ash is like plastic beads. Now coming to microscopic examination, it has rounded, smooth, fine and translucent threads. Sometimes it has shiny appearance. Let us come to the instrumental analysis now. The first one is the infrared spectroscopy. Now infrared absorption traces of a substance are individualistic in nature. If the patterns of absorption of the infrared rays of the crime sample correspond with the standard sample, then the common source may be identified. IR spectroscopy can be employed to study and identify the chemical composition of fibers as with all other spectroscopic techniques. A graphical representation denotes the basic infrared spectrum wherein light absorbance is plotted on the vertical axis and wavelength or frequency is plotted on the horizontal axis. Then comes the Fourier transform, infrared spectroscopy, that is FTIR. It is based on the absorption and wavelength of light in a fabric polymer and can be used on a single fiber. It is non-destructive in nature. This technique shines a beam containing many frequencies of light at once and measures how much of that beam is absorbed by the sample. Next, the beam is modified to contain a different combination of frequencies, giving a second data point. This process is repeated many times. Afterwards, a computer takes all these data and works backwards to infer what the absorption is at each wavelength. Then is the pyrolysis gas chromatography. In this technique, the synthetic fibers are pyrolyzed under controlled conditions. The fiber gives degradation products which are characteristic of the material. The chromatograms of the crime sample and the specimen on comparison may indicate the common source. This is a chromatographic technique in which a solid sample is directly converted into gaseous form and then ultimately it is analyzed. Let us now conclude our lecture. Fiber as a trace evidence is very important evidence in the field of forensic science. It needs to be properly compared and examined with the purpose of determining the source of its origin. For comparison and examination, various factors are tested and instrumental techniques are then applied. With all these information here, we come to the end of today's lecture. Do keep in mind what we have discussed today. I will be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. And now thank you for your time today. I will see you in the next lecture. Have a great day.